Okay, this is exercise 4.4. We're going to try this again. I just recorded this entire exercise. It took me about a half an hour, and when I finished the video I realized I didn't have the volume turned on. So it was a silent movie of sorts, so this time it will go a little better. We'll have some sound so you can follow along. We're going to grade. This is a handicap ramp. So the ramp starts up here and goes downhill. Arrows point downhill to here. We know that the drop, this is your highest elevation, 72.4, and they say that the vertical drop is 5.8 feet. So from here all the way down to this corner here, it drops 5.8 feet. So if you subtract 52.4, subtract 5.08, you'll get 67.32 feet. So if you just take the 5.8 that they give you here, subtract it from this, that gives you your lowest elevation. Now what we're looking at here is, go through the greater ramp with uniform slopes. Total change is in elevation is 5.08 feet. Critical spot elevations provide the critical spot elevations at 1/100th of a foot, which is 2 decimal points, and the critical elevations are at every one of these corners. So we're going to provide them all the way down at every corner. Those are the critical spot elevations. Show the required handrails. This is a ADA ramp, and handrails are required, and you have to maintain a minimum clearance between those handrails, a clear line of travel of 5 feet. And since this drawing is at 1/8 scale, 1 inch equals 8 feet, if you measure this with our 1/8 inch scale, find my scale that I had a few seconds ago, you'll see that it is, let's see, just turn into 1/8 scale right here. This drawing is, this ramp is 6 feet wide, so we can come in a 1/2 foot on each side with a handrail and still maintain 5 foot of clearance. So we'll do that at the end. We'll put the handrail or the handrails on the end. Label all parts of the ramp. Parts of the ramp, that would be the slopes, which we've got to figure, the cross slopes, and then the handrails. So label all parts of that. Label slope of each ramp leg. Okay. Provide 2% cross slope for drainage where needed. So because this is the high point and this is the low point down here, the slope is going this direction. So we need to have a 2% cross slope going this direction. We need 2%. And we need a 2% cross slope going this direction. Because water's coming downhill this way, it has to drain across and then continue down. Because we aren't providing any drainage or eliminating drainage. That's why we have to do a cross slope. We don't need a cross slope here because the water's coming this direction and the slope of this ramp is the same direction. So it doesn't need a cross slope. That's what they mean when they say provide a 2% cross slope for drainage where needed. Landings. Landings, you can have a maximum, these are ADA, American with Disability Act. These are the requirements for a ramp. Let's measure real quick, just see how long. This is a section of ramp right here, and it is, see that, 28, 29, 30 feet. So this is a 30-foot section of ramp, and this is a 30-foot section of ramp down here. So we have 30 and 30, and then this section of ramp here, from here to here, you can see is 20 feet. 20 feet. So this is 20 feet. And the reason we have to do this kind of horseshoe ramp is because the maximum distance you can go for a ramp without having a landing is a flat area. This landings on these slopes cannot exceed 2% or 1 to 48. So this ADA ramp can slope between 5 and 8.33%. That's the range of slope on a ramp. Then when you come to a landing after 30 feet, you have to have a landing that is 1 to 2%. And we're using 2% because that's the criteria of this assignment. We're using 2% for the landing. That gives a wheelchair user a spot where it levels out so they can rest. You don't want to have them go over 30 feet, and especially like going up the ramp. You have to go 30 feet. If this whole ramp was sloped, that would be a long ways. These landings are essentially resting points along the ramp. So that said, slope handrail extension areas at 2% downhill. So this dashed line here and this dashed line here indicate the handrail extensions, and these slope 2% downhill this way. And this one's coming downhill this way, so it slopes 2% this way. And what a handrail extension is, you have to maintain, if this was, you would have a sidewalk or stairs going this way, something that this ramp is tying into. You have to provide a 5-foot clear zone up here, right? A line of travel this way. Well, you have to extend the handrails for a foot at the top of the ramp and the bottom of the ramp, and you can't have those handrails extending into that 5-foot traffic lane up here. So you provide a flat spot for that handrail extension. And so here's from the book, here's the picture of these handrail extensions. At the top, you have a handrail extension, and at the bottom, this is 1 foot handrail extension. And then maximum slope for the ramp is 8.33%, and the minimum would be 5%, just because if the slope is 5%, if it's over 5%, that's when you need a ramp. So basically in between 5 and 8.33%, but you can't exceed 8.33%. So with that, we'll get started on this. Tie this down. That. And tape this down real quick. So first thing we're going to do is locate corner here, here, and here, because we know that this slopes downhill at 2%, and the distance is 1 foot, and we don't know what the vertical is, but we do know the horizontal is a foot, and we know that the slope is 2%. So vertical equals horizontal times slope. Horizontal is 1 times 0.02, which is 2%. So that equals 0.02. So you have to subtract 0.02 from this elevation to get this spot elevation here, which gives you, this would be 72.38. And then from here to here, we have to have this 2% cross slope. So this is 6 feet horizontally at that same 2%. So it's 6 feet times 0.02 equals, and that equals 0.12. So 6 times 0.02, 0.12. So this is going 6 feet at 2%, this cross slope right here, right? So 72.4, you have to subtract 0.12 from that number, and you have to subtract 0.12 from this number, and you get 72.28 for this corner, and you get 72.26 for this corner. Now we've got to calculate what these slopes are. We don't know what the slopes of the ramp are. We know that we've got the horizontal, it's 30 feet. we don't know the vertical, we don't know how much it drops from here to here, and we don't know the slope, and we have to have 2 out of the 3 to do the calculation. So we've got to figure out what the slope is before we can calculate what the vertical drop is. This slope, to calculate the slope, we have to measure, or we have to remove this drop for the handrail extensions, and we have to remove this drop, this is 6 feet. This landing is 6 feet wide. Just measure it. It's 6 feet, and it drops. The landings have a slope of 2%. So 6 feet times 2% is 0.12, and we have 2 landings, so we lose 0.12 feet at each landing. So there's 2 landings times 0.12, that equals 0.24. That's the total for the landings. And then at each handrail extension, that drops, it's 1 foot at 0.02, so it drops 0.02 here and drops 0.02 here. So you've got to do 2 times 0.02 equals 0.04, and that is for your rail extensions. We'll just write RE for rail extension. So those 2 numbers added together is 0.28 feet. So you lose 0.28 from your vertical for your handrail extensions and your landings. So we've got to subtract that from our total drop, which our total drop was 5.08 feet. It says up at the top of the plan here. So this is that total drop is 5.08 feet. We've got to remove this, and that's what remains for the ramps. And that equals, so we'll go the total 5.08 minus 0.28 equals check here, 5.08 minus 0.28 equals 4.8. No, yeah, 4.8. So your total drop for the ramp vertical is 4.8 feet. So we'll do 4.8 feet. So now we know for the ramp, we know that we've taken out the landings and we've taken out the rail extensions. So we know that the ramp drops 4.8 feet. So we have the vertical and we have the horizontal, because we know that the ramp is 30 feet plus 30 feet here plus 30 feet there. So that's 30, 60, 80. And we're going to figure out what the slope is. Slope equals vertical divided by horizontal. So the vertical, 4.8, divide that by horizontal, which is the total horizontal, which is 80 feet, equals, oops, 80 feet. So 4.8 divided by 80 equals 4.8 divided by 80 equals 0.06. So 6%. So label this 6%. This ramp leg here is 6%, and this ramp leg here is 6%. And with that information, we can continue and find what these spot elevations are at these corners. So this is, we got to find what our vertical is. Vertical equals horizontal times slope. We know that our vertical, or our horizontal, is 30 feet. We know that our slope is 6%. So it's just 30 times 0.06 equals 30 times 0.06 equals 1.8. So this drops 1.8 feet from here down to here, so just subtract 1.8 from this number and 1.8 from this number to give you those two elevations, which gives you 70.58 and 70.46. And if you did the math here, you've got the vertical, you've got the horizontal, you could calculate that this is 2% slope, which is what we need. That creates 2% slope. So now if this is 2% from here to here, at the top of the ramp we want these to be the same elevation, these two corners. So when they're coming down or up, this is flat here, this is going to be 70.46. that's the elevation there and there. If this drops to 2%, 6 feet, this is 12 feet because it's 6 feet and 6 feet. So if this is 2% here, this has to be 1% and 1%, so that you get to the same elevation here and here. So if we go 6 feet at 1%, so we figure out vertical, horizontal, 6 feet times 1%, it drops at 1%. 6 times 0.01 equals 6 times 0.01 equals 6 times 0.01 equals 0.06. So if we subtract 70.58 minus 0.06, we get 70.52 for this corner. 70.52. Now we've calculated all those. We've got to do these two spot are the same elevation. So now we're doing, instead of going 30 feet, we're going 20 feet at that 6%. So 20 feet times 0.06 equals, because we're trying to find the vertical again, which is horizontal, 20 feet times slope, which is 6%, equals 20 times 0.06 equals 1.2. So we've got to subtract 1.2 from this elevation. Both elevations are the same, so these two elevations down here are going to be the same. So if we subtract 70.46 minus 1.2, we get 69.26 for this corner, 69.26 for this corner, and then we have this 2% cross slope that we've got to maintain on this ramp landing. So we have 2% going here. If we have 2% from here to here, which is 6 feet, then from here to here, to get to that same elevation, we're going to have to go 1% and 1% this direction. So from here, 6 feet at 2%. So what's we're trying to figure vertical equals horizontal times slope. So 6 feet times 0.02, which I think we did right here. 6 feet times 0.02 equals 0.12. So we subtract 0.12 from 69.26. 69.26 minus 0.12. 0.12 equals 69.14. So if this is 69.14 and we want to get going this direction, we have to get down to that same elevation, right? So if we went 2% 6 feet, then for 12, 6 and 6, we got to go 1%. And if we do that, we go 6 times 0.01. Do we have it on here? 6 times 0.01 equals, right here, 0.06. So we subtract 0.06 from this elevation of 69.26, we get 69.20. So now we've got all these spot elevations. We just have to do this one here and here. So it's 30 feet again, just 30 feet at 6%, 6%. It drops 1.8 feet from here to here and here to here. These elevations now are different, so we have to subtract it from this one, then we have to subtract from that one. and we get 67.46 here. And if we subtract 1.2 from this, or no, 1.8 because it's 30 feet, then we get 67.34. 67.34. And then we've got to drop another, at 2%, we're going horizontally a foot for this handrail extension, and that is 1 foot times 0.02, so we got to subtract 0.02 from this to get this corner, and this is 67.44. So those are all the critical spot elevations for this ramp. Last thing we have to do is put a hand railing in, and since we measured this and it's a 6-foot ramp, we have to have a minimum of 5-foot clearance, so we can come in a ½ foot on each side. I'll draw this in red so you can see the handrail better. So one goes there, ½ foot there, ½ foot there, and there. We'll just draw this in. Oops. So that goes there. I drew to the end of the handrail extension, and then I ended it just a little short because we're going to curve the corners instead of making them 90 degrees. So let's do this one. Same thing over here. Same thing down here. So here's ½ foot, ½ foot, there, and there. So we'll draw this handrail, and this handrail. Again, ending at the handrail extension. Last one we gotta do is the handrails over here. The ½ foot, and ½ foot and ½ foot. So we'll do. And then we just round the corners. They could go 90 degrees, but typically it's nice to round the corners. So there's your handrail, which you can just label handrail. And then what I like to do is just put typical. And then that means this is all the handrail. On one plan sheet, I like to label as few times as possible so that if you make an edit, you don't have a bunch of different labels that are the same that you have to catch and make sure that you change them all. If you just do it 1 or 2 times, then you have less chance of error. So there's our handrail label. There's our slope label for the ramp. And there's our cross slope. And then there's our horizontal distances. So if you label those on this plan, that will complete this assignment.